Welcome to Lunch with Tech Leaders, where we have engaging conversations about software development and cloud engineering with industry leaders and subject matter experts. These episodes are created by the Great Lakes Tech Leaders, an online community of technology practitioners. Please come join the conversation by visiting gltl.rbn.ai. Again, that's gltl.rbn.ai. Now strap in, because we're deploying to production in 3, 2, 1.
All right, so welcome to the latest episode of Lunch with Tech Leaders. My name is Jason Brown. I'm a cloud solutions architect with Right Brain Networks, and I'm your host for today. Joining me as co-host is software and data consultant Tom Kowalski.
Hello.
Also joining us today is business technology consultant Joe Coleman.
Hey there. Thank you so much, Jason. Just throwing it out there as well. If you folks listening in have any questions at all during the conversation here, go ahead and throw it in the chat to this channel, and I'll be sure to interject and make sure the topic gets covered. So thank you so much, Jason.
Awesome. Thank you, Joe. And we have two guests today. So first we have subject matter expert and recurring guest on the podcast, Preston Frazier, senior software engineer from the Interoperability Institute. Welcome back, Preston.
Thanks, Jason. Good to be here.
All right, and we have our new guest, David Miser, product engineer, also from the Interoperability Institute. Welcome, David.
Hey, Jason. Thank you. Great to be here.
Awesome. All right. So in this episode, we're going to discuss event-driven serverless architecture. We've got a lot to cover today, so let's go ahead and get started. So yeah, I guess I'll kick off the discussion with a question to you, Tom. So kind of get an understanding of what event-driven architecture is. So would you mind kicking things off by describing exactly what is event-driven architecture and how it differs from traditional architectures?
Like with everything, you kind of throw out there that it depends. And also, too, a lot of terms like this, buzzwords, serverless and DevOps, right, they kind of morph and change, especially as, companies get involved and start using it as marketing terms. Like event-driven can be, all over the place with different products that people sell. But I think it's, kind of self-explanatory, right? Like other ones, right, it's kind of have to read into or, understand what's going on. But I think the title kind of explains it so very well. Event-driven. As events happen, it kind of drives your application and what it does. And kind of thinking in terms of that, like every application, right, you have, things are happening and, actions are being taken off of that. But the event-driven architecture, I feel, is kind of puts that in the forefront where, you're constantly thinking of that as the data flows as events. So
yeah, and I think a real good kind of example or the best way to kind of frame that is that when we talk about not real time, but when we talk about event-driven architecture, that's kind of different from the traditional sense of a request and a response, where you have a system that makes a call and then they get a response back. Whereas event-driven, which I think we'll talk about today and define it as this, is where events are published and then they're consumed. There's a loose decoupling of the systems. They don't necessarily depend on each other for success.
yeah, I think that's a big portion of it there. The asynchronous nature of it, right? This event happened, and other consumers can handle that event as they need.
Right, absolutely. Yeah, and that's can lead to a lot of significant advantages over a traditional architecture. So one of which you guys already mentioned is the decoupling, right? Having this very loose coupling of different components working together to handle these events, right? So I'd like to kind of dive into that a little bit more too. So what would you consider to be some of the significant advantages that an event-driven architecture can, what significant advantages do you think they would have over traditional approach, like particularly with serverless, from a serverless context?
Just at IOI in general, we prefer a serverless architecture from scratch, in part because you're not paying for anything if you're not using it. And so if you use that event-driven model, especially the way AWS provides it with API Gateway and Lambda. When you think about your service, you really think about it with what event starts an action and how does that action flow. And so, in a traditional kind of model, if I had an API that I was providing, I'd spin up Nginx and I'd put maybe Flask behind it, and it'd be running either on a container or on a server, and it'd be there ready to respond at any given time. And so that's constantly there. It's a baseline cost. Maybe you scale up from there. And so you're paying that baseline cost. But the way we've done it internally at IOI is we've really stepped into this event-driven architecture. We actually start with our events with, okay, so what happens on the front end, right? Maybe a user clicks a button. That button ties to an API. That's an event, right? So the event kicks off with an API call, and then it continues on the back end. Maybe the API responds immediately, or maybe it kicks off a workflow. But the point is that we could have that event called a million times, or we could have that event called once a month, and we only pay for what we use in that scenario.
So that's interesting how you said some of them are responded immediately and some kick off a workflow. Do you kind of differentiate that, or do you kind of like keep the same pattern, but the workflow is to respond immediately? Like how often are you doing one with the workflow and one where you're responding immediately?
I'll let Preston take this one.
Okay. So, I think, David, you're talking about just the volumes, really, right? We get data in. And maybe I wasn't following closely as well. Maybe you can go ahead and explain it, David. I'm not exactly sure what you...
Well, maybe it's my question, right? So how often... So does your front end expect to have a response coming back? Or do you always build, the front end where it can be asynchronous in nature, right? Like it's maybe polling or getting I don't know if you're using WebSockets, getting a message back saying, hey, the workflow is done or the job completed. Or are you building your event-driven architecture with that respond immediately? Or are you polling for the result?
I think it depends on the user expectation, right? So if it's an API, there's always an expectation that you return something. It's got to be, maybe a 200 or a 404 or 500, whatever. And so there's an expectation that you return something on the front end. But even in the back end, sometimes our processing, might take days sometimes. But what we provide is that callback URL model in those cases, so you can monitor the status of your job via callback URL.
Really, and okay. So I think I understand what you mean now, David, and that's saying that you can submit a job and immediately return, say, a URL where you can, poll for a status, and a job can be running kind of asynchronous to what's going on the front end. I think that's one way of kicking off a job. I wouldn't necessarily say that's kind of the event streaming that we're talking about with event-driven architecture, but that certainly, you triggered an event to run and it kind of pushes into the system. So I think there's two kind of like ideologies about event-driven architecture. There is the data streaming where you're just publishing events somewhere, and you as the producer, you don't care about them after you published them. But then there's the events where you produce something and you are expecting something to happen and potentially return to you. So I think there's those two flows, and we can just keep those in mind as we go.
Yeah, that's interesting, right? It's kind of like the external events to your system where other systems can consume those. And then there's kind of the idea of event-driven architecture internally, right, within that system of events happening. I just pose that question of, is it always a job? Because I'm working with kind of like a framework where it is always asynchronous, and the response that you always get back with the API is 202, right? It's
Right.
In process, and you have to either pull or you get, a webhook if you use WebSockets or GraphQL, right? Yes, subscription, and letting you know that the job is done. So yeah.
Yeah, and oftentimes what we do is we take an event and we put it on a stream or a bus of some sort where there's a downstream listener. So even in the scenario where the event is actually a user event, more of a service.
Is it internal
Those.
to an application, or is it put out as plus to the other applications?
Right. So our one of our primary applications is actually traditionally service-oriented architecture, right? So there's a service that's available on the network, there's a request, there's a response. And what we've done on the back end is we've separated that service from the additional downstream validation and processes that happen. That's actually our big thing that we're working on, our HIE platform. So we take that service-oriented action that the user is performing. I say user, but in this instance, it's actually service to service. And then we convert that to an event bus using S3 action. So we listen downstream to those S3 event actions, and we've decoupled our service tremendously and sped up parallel processing along the way using Lambda and SQS and DynamoDB and a lot of other things. Sometimes in ways that might seem non-intuitive, but.
That's interesting you say S3. How do you maintain the contract between the services, right, of what's going to be in the S3 object? It's hard enough, right, doing with APIs, but when you have a blob, how do you maintain the contract so the downstream, knows what's going to be in there, right? And how do you version that?
Yeah. So what's great about especially S3, which is why we love it as an event-driven architecture, or as a starting point for our actual internal event-driven architectures, is that Amazon publishes both to their new event service as well as you can publish these to SQS and SNS when an object is created, modified, any of the traditional CRUD. One of the reasons why we love S3 is that S3 will publish create, read, update, delete. Not read, but create, update, delete events to S3 as well as the relevant location. So Amazon actually provides, as you said, the contract for what gets published onto that bus, and then we're able to consume those messages downstream.
Oh, okay, but you don't have anything in place of the syntax of what's in S3 though, right? Or is that you kind of always, it's just the same file in S3, so you always know?
If you're talking about kind of the payload that's produced in the event, it's a consistent payload that AWS produces and documents.
Okay. I'm talking about the object itself in S3 you mentioned, right?
Well, I think this is one of the advantages of S3 providing the object, right, versus needing to validate the file up front. Because what we can do is we can consume that file without having to do validation on the front end. So we actually consume the file a lot faster, persist it to S3, and then downstream we can perform validation later.
In this case, the S3 notifications or events, Amazon doesn't provide the binary content of the file that's uploaded. They just pass references to that in S3. So for those notifications, the actual content of the event is not with those notifications. It's just a reference to S3. And so you have to pull that from S3 later if you want to use the actual application content, which is different from some other messaging platforms like Kinesis or Kafka, where the entire content is published to the message bus.
Yeah. Okay.
Yeah. So we've been talking a little bit about the different common components with the different workflows, right? For event-driven architecture, you've got your event source or your producer, the event broker, and then also the consumer. And so we've been kind of spending some time on the event source, and you guys are talking about S3. So what other kinds of event sources do you guys typically see or can you think of? And, that also kind of what different tools would you use for brokers and consumers, and how do you choose the right tool for the job?
Yeah, I mean, just some different event sources that we use in AWS, as we've talked about, S3 to make notifications. SQS also can produce notifications for serverless components to pick up from. I mentioned Kinesis data streams is another one. SNS, Simple Notification Service from AWS, is another one. AWS in particular has really provided a lot of event sources that you can trigger, downstream processes off of, lambdas, or, you can trigger data to go into queues in AWS. So certainly a lot of event sources. And you talked, and just to, finish the question, you talked about what is good to be writing or consuming, producing or consuming. It depends on your workflow for sure. We have a lot of lambdas at IOI that we consume data from these various event sources. And, if you're working with that kind of small, short request type of architecture, lambdas can be good to write to these sources as well. I think we talked about it a few podcasts ago. If you're doing a lot of large data or batch file processing, you might want to be running a Docker container, maybe Kubernetes or an ECS, where you can run a task for a long time and do a lot of producing to one of these event sources. You may not want to have one of these containers consuming data, because that kind of might defeat the purpose of the event drivenness of receiving those events. But certainly to produce a lot of data, having a long running container is nice.
So my take on it is, and what tools and technologies, especially in the AWS sense, is, you can use whatever you want, right? That SQS, SNS, whatever, internally, right? For one application or service. But when you're interacting with other application services, I like the good old fashioned webhook, right? And then just let any of the downstream services consume that however they want, whether they convert it to SQS and use whatever other AWS tools, but kind of standardizing that boundary between the services where it isn't necessarily or Amazon specific. Not that there's, the ideas of lock-in and things like that, but it just really allows that flexibility, and for us kind of establishing that contract, because it's very clear, like, this is the webhook, this is what it's throwing. Then you can do whatever you want with it, with your technologies, with your service and how you're consuming it. But that's me and how I've been doing it.
Yeah, I think one of the unfortunate things that we have in healthcare is that healthcare runs a little bit behind the times, and isn't necessarily up latest and greatest in terms of technology. So a lot of our vendor partners that we work with are just not prepared for that sort of model. But that being said, they are willing to push in, and we're starting to see our vendors in particular implement Kafka. Multiple of our partners have been willing to integrate with us over Kafka. Unfortunately, not in a way that we can consume events, but as time goes on, we expect to start seeing more of that, where they're willing to put the events onto Kafka for us to consume. And as they mature, hopefully we're able to integrate with them over Kafka, because that would be tremendous, especially with AWS's ability to convert even those Kafka messages into Kinesis messages, which we would prefer as being all in on AWS.
Yeah, it's not just healthcare. It's all of them. And even when you see like, oh, we're doing, very modern development, it's usually just one team within an organization. When I notice everybody has a lot of legacy stuff, all the industries.
I think one of the cool things, though, maybe it's cool to me, if you have the time and potentially the money, you can set up, one of Kafka or Kinesis, and you can start publishing these events there in preparation for a time when third-party clients or downstream systems are capable of reading off of those data sources. Data sources are, streams. So, it's something, we go back to the loosely coupled thing. You can have it set up and it doesn't really depend on the downstream service being ready, but those events can be published and potentially replayed by the downstream system when it's ready. So definitely a bonus if you're, preparing for something and integration later on.
Yeah.
All right. But yeah, so I wanted to dig in a little bit. You mentioned healthcare, which is the realm that you guys are working in. How has utilizing event-driven architecture been particularly advantageous in healthcare for you two? And then also, like, what other industries do you guys all see using an opportunity for using event-driven architecture more heavily?
I think one of the great ironies of healthcare is that healthcare is actually event-driven itself, right? Like, you walk into a clinic and an event occurs, right? You're seen by a doctor. That's actually what we do, particularly at the Myhin family of companies, is we act as a message broker between different healthcare providers, as well as insurance companies as well. So we broker messages between them, and those messages themselves are event driven. So when you step into a hospital and you're admitted to a hospital, that generates a message. When you're seen by the doctor, that generates a message. When you're maybe moved between floors, that generates a message. And then, finally you leave the hospital, that generates a message. And so all of healthcare is event driven from the get-go. And so one of the things, though, that we've seen is that the traditional model of handling these messages is very point to point to point, goes from point A to point B. Point B maybe processes the message and sends it to two more points. And all the current technology is built around that data flow. And so all of that occurs synchronously across the board, right? So somebody gets in a message, maybe they do 15 steps on that message, but they will perform all 15 steps and send that message on before they respond to the original sender. And so what our application and the whole point and purpose of our application is to really take that model and turn it into both a model that works for us as an HIE, because we're not sending it point to point, we're sending it point to many points. And then alternatively to take that and turn it into, instead of a totally synchronous process, into a totally asynchronous process. So that's what we look to do with event-driven architecture internally, right? Is to take those healthcare events and handle them in a way that is event-driven, in particular, so that our partners, we can pass along that savings, so that we can actually get down to a point where we can price for them at an event level, right? So how many events are we handling a month for them, and then we can price at the event level for them.
Nice. Are you using like a standard for all of your events, like a common envelope wrapper around all of them?
So our incoming messaging is all standards driven by the healthcare industry. So the healthcare industry, HL7 in particular, is one of the primary standards bodies. So HL7 kind of dictates what those messages look like coming inbound. So inbound messaging conforms to one of, basically three standards out on the market: HL7, CDA, and FHIR. FHIR is the new hotness, if you will. And so that's what those conform to. I think increasingly internally, we'll probably conform more towards the FHIR model. Right now, internally, we don't conform to any of those three. Really, we have our own internal method of communication that we use. It's JSON based, but it provides the critical information and the original message, and then we use that for most of our downstream processing.
Do you wrap them all in like a timestamp or like a session ID or transaction ID or key or anything like that you standardize across all of them?
Right, like every message we receive, they're time stamped, they're stored in S3. We consistently handle whatever message it is, whatever protocol we receive the message on, we standardize it once we get it in. And kind of like David said, we have a JSON reference of the message. We handle it the same way our system handles, the messages consistently. And, I was going to say, even though there are standards for the wrappers of the health care messages, we receive them on many protocols too, very common standard. And we're getting a little off topic maybe, but TCP, low-level connections, we receive a lot of messages on over VPNs. But that's not to say that other providers don't want to send via API or SFTP or maybe direct secure messaging, which is the email of messages to us. And so we have to support all those different messages, support those protocols on the way in, as well as support those protocols on the way out. And to kind of lead it back to the event-driven messaging, wouldn't it be really great if we could just either consume or publish those messages we get into a standard, with permissions, of course, and security, but publish those messages to some kind of stream where downstream receivers, all they have to do is subscribe to that stream and they get the messages that they're interested in. And that can save us a lot of scalability or costs of making requests to each of these downstream locations when we could just publish one place and then the subscriptions or consumers could consume from that. That could really be really performance increasing and cost effective for us as someone who does broker a lot of messages.
Yeah, it seems like a natural fit. So one of the things I think we talked about before, just while we have a couple minutes left here, we mentioned a challenge just for serverless architecture in general, one of which being observability, right? So with all of these like loosely coupled components all working together, it can be very difficult to keep track of what's happening with a specific event, without a robust monitoring system in place to be able to track where everything's going. What other kinds of challenges do you guys deal with when it comes to event-driven serverless architecture?
I think one of the lessons we're learning internally as we've really moved into the event-driven model, it's really great in terms of microservices. You can get very, very, very granular with your microservices. And that's great, like super fantastic. However, two things happen. Number one, cognitive complexity goes up. And so it's harder and harder to wrap your mind around the system and what the system does. You really have to zoom in on the system to understand what's happening at an individual level. So that cognitive complexity is going up. And then the second problem is we really have a lot of dependency issues where we have not gotten great yet at internal communication for when things change. And so we often have issues where we'll actually get into our UAT environment and find out that we didn't deploy some update that's required for some other update that was required for some third update. And so I think those are the two primary challenges that I, as a leader or a manager, I'm looking to solve those in this upcoming fiscal year to really make it so that both our external stakeholders, like our operations teams, as well as outside customers, and our developer teams really can have access to that information so that they can actually understand what the system is, what the system does, what individual components in the systems do, and then as well to really nail down this dependency thing and figure out how to keep track of our dependencies, or alternatively for us to get much, much better at deprecation rather than breaking changes.
One, and this goes along with cognitive complexity and dependencies, and that is either traditional architectured applications or third-party applications that may not scale with increased throughput of a serverless system. Mm-hmm. And understanding that is important. Otherwise, your system might scale fine, but when you start making thousands of requests to a downstream system, it might not be able to handle that. And you might need to consider orchestrating your architecture so you can throttle or rate limit certain integrations that might not be able to scale as well. But again, if you're not using a request response type of method and you're using an integration where you're only producing to a specific event stream, then you really don't need to consider the scalability of the downstream system, because they'll consume from your stream as fast as they can. They won't have to consume as fast as you produce. So that is a good advantage of that kind of event-driven architecture where one system produces and another consumes.
All right. Yeah, excellent points. All good to consider when looking into building event-driven serverless architecture. Coming up on time here, so I want to make sure we have time here for final thoughts. So, Dave, Preston, Tom, final thoughts before we wrap up for today?
Honestly, I love event-driven architecture. I think it's really changing the way we think about how we operate, both internally and externally. And I see it really taking off here as time goes on, and people really looking to turn things into events to achieve, both scalability as well as particularly cost. I think that's a huge benefit, to be able to just pay for what you use rather than have services that are running 24/7 that may not get used.
Yeah, agreed to everything that David said. I think event-driven architecture really models a lot of events in life, and there's a lot of great applications for it. So definitely, it's been around for a while, but definitely, I think, gaining more and more acceptance.
Great. Tom, anything to add?
I'd just like to add, I know maybe you want to talk about the next episode, but I'm going to steal your thunder and say that the next episode, I'm going to be hosting it or co-hosting it with Adam, and we're going to be talking about observation-driven design. And it's kind of like a little thing that we developed kind of on top of event-driven architectures. This is kind of fun talking about it. And if you like this, then definitely come next week when we talk about observation-driven design. Little plug in there.
Wonderful. Yeah. Thank you, Tom. And yeah, thanks, Dave and Preston, for joining us today. Really appreciate your insight and input. Yeah. And I want to also take the opportunity to thank all the listeners for tuning in to today's episode of Lunch with Tech Leaders. We hope you found the conversation informative and valuable, as always. We'd love to have you to join us again for the next episode that Tom had just teased. And as always, the episode will feature expert guests and interactive conversations, so be sure to tune in.
Thank you.
Thanks, everybody, and see you next time.